You are watching the Unit 1 lesson video on properties of real numbers. Now, you might find that a great deal of what you are going to watch today is review. So that's actually great news. You might just find that we're going to extend it a little bit further to algebra. So let's begin. On this page, you're going to see that we have a lot of notes, and there's not really much writing, so a highlighter right now would be very beneficial, or you can just underline, but I like to see colors. It helps my brain work a little bit better. So the first property that we are going to look at, and as you can see, they're side by side, so we have the commutative property of both addition and multiplication. So I'm going to highlight commutative. So the commutative property of addition and multiplication. If we read the definition, it says the order that the numbers are added does not change the sum, or the order that the numbers are multiplied does not change the product. So I'm going to just underline, or really, in my case, highlight order. In the commutative property, order doesn't matter. So let's see some of these examples in action. Here's the addition examples. So here it's saying a plus b is the same thing as b plus a. Well, negative 2 plus 7 should really be the same as 7 plus negative 2. Well, this is 5 and this is 5. So we're seeing that we can switch around the order of the numbers when we add them, and the end result, the sum, is always going to stay the same. It works for fractions, it works for any type of number, rational or irrational. And the same rules apply for the commutative property of multiplication. I can multiply in any order. So a times b is the same as b times a. And we can use whole numbers or integers. So 5 times negative 7 is negative 35. Negative 7 times 5 is also 35. So we can see that we can change around the order when we add or multiply, and the end result is always going to be the same. The next number property that we are going to review is the associative property of addition and multiplication. And if you read the definition, it says, the way that numbers are grouped when they are added does not change the sum. And the key word here is grouped. So let's highlight that in both the addition and multiplication. If we look at the examples, we can see that A, B, and C are in the same exact order on both sides of the equal sign. However, A plus B, the first two, are grouped together, where on the right-hand side of the equation, B plus C are actually grouped together. But really, the end result would be the same. So let's see this in action with actual numbers. Negative 6 plus 2 is negative 4, and negative 4 plus 7 is 3. So this left-hand side is actually 3. Let's see if this works out over here. Okay, so remember, when we simplify, we use order of operations, so groupings first. So 7 plus 2 is 9, and 9 grouped together with a negative 6 is also 3. So we can see that that balances out. It looks exactly the same with multiplication. However, instead of plus signs, you are going to see multiplication symbols. So for the associative property, the way that the numbers are grouped doesn't matter. Okay, so let's talk now about the identity. Okay, so we now have the additive identity and the multiplicative identity. One is on top of the other here. So we have the additive identity and we have the multiplicative identity. And they're a little bit different. So let's read the definition of the additive identity. It says when 0 is added to any number, the sum equals the original number. Well, basically what this is saying is add 0 to anything, that number is not going to change. So a plus 0 is still a. 3 plus 0 is still 3. So 3x plus 0, still 3x. Works for rational and irrational numbers. And you can even see we have a monomial happening. It even works for polynomials. Now the multiplicative identity is a little bit different, because if we multiplied something by 0, we actually would get 0 as the answer instead of itself. So when 1 is multiplied by any number, the product is equal to the number you start with. So a times 1 is a, pi times 1 is pi, negative 8 times 1 is negative 8. So the identity basically means that the number is going to remain unchanged. On the flip side, we have the inverse. And a lot of times people like to remember inverse as the opposite. So let's write that out. So now we know that the additive inverse and the multiplicative inverse are opposites of one another. So let's read the definition. The number that can be added to the original number and will give you a sum of 0. So basically, when you add something to the number you start with, you should always end up with 0. That's for the additive inverse. So if you start with a, you'll have to subtract a, or we will usually say add a negative a. If you start with a 2x, you have to add a negative 2x. If you start with a negative 3, you actually have to add a positive 3 to get 0. Now the multiplicative inverse is slightly different. Instead of having a number give you 0 as the end result, we actually want a product of 1. And notice how this is connected to the identity. So the additive identity is, the identity element is 0, and the multiplicative identity, the identity element is 1. So 0 and 1. Now what we're trying to do with the inverse is actually get back to that number. So if we start with a, with the multiplicative inverse, we have to multiply it by 1 over a to get 1. That's really a divided by a. Or 5 divided by 5, or 5 times 1/5. It's the same thing. Gives us 1. 2/3 times 3/2. You might say, hey, that's a reciprocal. And you're right. It will give you 1. So those are the identities and inverses in action. Moving on to both the addition and multiplicative property of equality, you will find that these properties only will exist when you're solving an equation. So for the addition property of equality, if you add the same number to both sides of an equation, many of you call this like balancing, the sides remain equal. So if we look at the first step here, we are given the equation x minus 3 is equal to 7. Well, if we want to take that negative 3 and move it to the other side, we're just going to add 3 to both sides of the equation. Some of you remember, and you might say like, oh, I don't show it like this. I show a plus 3 underneath that negative 3 and a plus 3 underneath that 7. Same difference, okay? So this is really the addition property of equality. Now the multiplicative property of equality works the same way. This is usually going to happen when you get to the end of a problem. So here we can see we have 2/3 x is equal to 8. So to get rid of this 2/3, we are going to multiply both sides by 3/2. That's the multiplicative property of equality happening. Some of you might say, oh, well, what if I just had 2x is equal to 8? So let's write that off to the side. So what if I just had 2x is equal to 8? And you're like, well, I would have just divided both sides by 2. That is also the multiplicative property of equality happening. We're just showing it a different way. Okay, moving on. The distributive property. I think a lot of us like this property the best. It's really easy to see because whenever you have a number sitting outside of parentheses and you multiply it into the parentheses, you're distributing. You can see these examples down below. Oops, let's try that again. You can see these examples right here. And the definition says when you multiply a value outside of the parentheses to each term inside the parentheses. And our last number property is a multiplicative property of 0. We typically don't see this very often. That's why it's last. But the multiplicative property of 0 basically states that if you multiply anything by 0, you get nothing. You end up with 0. So if you multiply by 0, you end up with 0. So moving on to exercise number 1, all these parts want us to determine which number property was used to get from step A to step B, and then we need to explain how we can tell. So let's begin. If we look at A, we have step A and step B. I started with 12x minus 9, and somehow I brought in parentheses into the mix. Now, a lot of you might think parentheses, parentheses, parentheses. Well, that could probably either mean associative or distributive. Let's kind of narrow it down. So did we change the order, or did we maybe use a factor? Did we pull any numbers out or multiply any numbers in? Well, maybe some of you might see it a little bit easier. If I multiply 3 to 4x, I get 12x. If I multiply 3 to negative 3, I get negative 9. This is actually the distributive property. And some of you might say, well, really, isn't the distributive property when you multiply? Well, yeah, you're right. This is the backwards distributive property. This is what we call factoring, but still we use a distributive property to get to the end result. So we can see that this is a distributive property because 3 times 4x is 12x, and 3 times negative 3 is negative 9. Continuing on to B, we can see that there's 2 steps here. Obviously, step A and step B, like there were in part A. And step A is negative 4a plus 4a, and the end result is 0. So let's think back. What number property would let us take one number, add the opposite, and get 0? If you are thinking additive inverse, you are correct. So if we write this out, it was the additive inverse because the opposite was added to get an answer of 0. Now as we move on to part C, it looks like there's parentheses going on. Now that may or may not have anything to do with the number property that's used, but that's certainly one thing that I think of. And it appears that the 3x, the 5x, and the 7, they're all in the same order. So commutative property's out. But it does look like the numbers were grouped differently. So what number property lets us group numbers differently? Well, that would be the associative property. So is this the associative property of addition or multiplication? And some of you might say, well, there's a subtraction sign in there. Well, it still is the associative property of addition. There's only the associative property of addition or multiplication. There's no subtraction or division. So let's use that and write out why. So the associative property of addition was used because the numbers were grouped differently, but the order didn't change. So if the order had changed, then we probably would have talked about the commutative property. All right, the last part of this exercise number 1 is D, and it appears that we are taking negative 3/2 and we are multiplying negative 2/3, and we get an answer of 1. So let's think. If we start with a number, multiply it by something, and get an answer of 1, what number property is this? Well, if you are thinking the multiplicative inverse, you are correct. So in writing, it would be the multiplicative inverse because we multiplied a number by its opposite to get 1. Moving on to exercise number 2, the directions say that each equation below has been solved for you. We need to write the number property that was used to obtain the equation to the left. So let's start with part A. We start with the equation 3x plus 5 is equal to negative 13, and somehow we ended up with 3x is equal to negative 18. Well, we can't really see what happened here, so maybe what we might want to try to do is solve this. Many of you might say, well, you know what, we need to get x alone, so we probably should be subtracting 5 from both sides, because when we do that, a positive 5 and a negative 5 result in 0. So what number property allows us to balance an equation using addition or subtraction? If you answered the addition property of equality, you are correct. All right, so we have one more number property to identify. And now we have 3x minus 8, or 3x, not 3x minus 18. 3x is equal to negative 18. So how would we get x alone? Well, many of you might say, well, let's just divide both sides by 3. So what number lets us either multiply or, in this case, divide both sides to get our end result? Well, we're not looking at the addition property of equality. Now we're looking at the multiplicative property of equality. Okay, let's go ahead and move to part B. So we start with 3x plus 7 is equal to 4x, and somehow managed to get negative 1x is equal to negative 7. Now, stick with me here for a minute because some of you might not have learned this process yet. Now, if you didn't learn the process of sorting, it's okay. We're going to do much more of this in the video that we're going to see next time. But what it looks like the person did here was that they moved all of the x's to the left side and all of the non-x's to the right side, in this case constants. So it looks like they took the 3x, left it be because it had a variable, and they moved the 4x to the other side. Now whenever you move a variable or anything to an opposite side of the equal sign, the sign will change. So instead of a positive 4x, it's a negative 4x. And then the plus 7 moved to the other side and became negative 7. And then, of course, they just grouped together the 3x minus 4x to equal negative 1x. Well, some of you might be like, whoa, that was mind-blowing. Again, like what I said is that we're going to do a lot more practice with the sorting method in the next video, so don't get really stressed out that you didn't follow that completely. But really what we need to talk about here is that we flipped the sides of the equation. We took one of the terms and we moved it to the other side and made it negative. That is actually the addition property of equality because we were able to add and subtract things to either side of the equation to keep the balance the same. Okay, now moving on, in the last step, we can see that we needed to get x alone, and it was actually being multiplied by negative 1. So let's divide both sides by negative 1, and we end up getting the final answer of x is equal to 7. So again, you guessed it, this is the same thing as in part A, the multiplicative property of equality is being used here. Okay, great, let's move on to C. So C, we have 2x minus 11 minus 4x is equal to 0. And in the next step, what happened? Well, it looks like the 11, or rather the negative 11, and the negative 4x just changed order. They didn't change their sign, they changed the order. So what number property lets us switch around the order? Well, that would be the commutative property. So are we dealing with adding or subtracting, or dividing or multiplying? Well, we're dealing with subtraction, which would really be the commutative property of addition. Now, as we look at the next step, it appears that a couple things actually happened here. It looks like the 2x minus 4x was grouped together to become negative 2x, which we can see right down here. But then this negative 11 is not a negative 11 anymore on the left side, it's actually a positive 11 on the right side. So what this person must have done is they probably added 11 to both sides. There is the additive inverse happening, but what number property lets us add to both sides of the equation to keep it balanced? Well, you got it. We use it in A and B, the addition property of equality. Now our last and final step, we need to get x alone. So you probably just start saying, well, let's divide both sides by negative 2, and you are correct. So x is equal to negative 5.5. We used the multiplicative property equality yet again. So the last and final question of exercise 2 is the equation half all times 8x minus 10, and that all equals 1. So that somehow became 4x minus 5 is equal to 1. Some of you are thinking, I know that you guys know this one. This is the one that you like. I love that you're thinking this. The distributive property. If you are thinking that, you are absolutely correct. So half of 8x is 4x. Half of 10 is 5. So the first step would be the distributive property. And if we look at 4x minus 5 equals 1, well, how did that become 4x is equal to 6? Well, it looks like that negative 5 just moved to the other side and became positive. So some of you might say, isn't that just adding 5 to both sides? You're right. So again, the addition property of equality is happening here. And last but certainly not least, we needed to get x alone. So we divide both sides by 4, and we end up with getting x is equal to 6/4, but that actually simplifies to 3/2. But more importantly, what number property was this? The multiplicative property of equality. So that completes the lesson. Hopefully you have a little bit of a better understanding of the number properties and how they're used in solving equations. Very nice work.